Look at any monkey. The first thing you notice is not its face. It is the tail. Long, flexible, always moving, helping it balance and grip like a fifth limb. Now look at yourself. No tail. And here is what nobody tells you. Your ancestors had tails for millions of years. They worked perfectly, and then something switched them off permanently. Not just in humans, in every single ape on the planet, all at once. The reason why is one of the strangest accidents in the entire history of life on Earth. To understand why ancient humans lost their tails, you first need to understand how useful a tail actually is. Because losing one was not a simple upgrade, it was a massive trade. Monkeys use their tails every single day for survival. When a monkey sprints along a branch at full speed, the tail acts like a built-in balance pole. Every sharp turn, every sudden jump, every mid-air correction is controlled by the tail automatically. Without it, moving through trees at that speed would be nearly impossible. Some monkeys in South America took this even further. They evolved tails strong enough to wrap around a branch and hold their entire body weight. Both hands are completely free. This meant they could eat, groom, and grab food without ever needing to grip a branch at all. That is not a small advantage. That is essentially an extra limb that costs almost no effort to carry around. So the obvious question is, why would any animal willingly give that up? The answer is that no animal willingly gave it up. Something else happened entirely. And it started roughly 25 million years ago with a group of primates that began moving through trees in a completely new way. Around 25 million years ago, the ancestors of all modern apes stopped running along the tops of branches and started hanging below them. This sounds like a small change. It was not running along the top of a branch requires a tail for balance, but hanging below a branch is completely different. When you are suspended underneath, swinging arm over arm, a tail does not help you balance. It just hangs there. And a long, heavy tail swinging around while you are moving through dense forest gets caught on branches, slows you down, and costs energy to carry. For this new style of movement, a tail was not an asset anymore. It was starting to become a problem. Watch a gibbon swing through a forest today, and you will see exactly what this looks like. Pure speed, pure precision, arms doing all the work. A long tail trailing behind that animal would be a liability, not a tool. So slowly, over many generations, apes that happened to be born with shorter tails moved more efficiently. They survived better. They passed that trait forward. And over millions of years, the tail got shorter and shorter until it disappeared almost entirely. But here is the part that nobody expected. The tail did not just fade away gradually through natural selection alone. Something much more specific happened at the genetic level, and scientists had no idea what it was for decades. For a long time, scientists knew that apes had lost their tails. They could see it clearly in the fossil record, but they had no idea what specific genetic change had caused it. They could see the result. They just could not find the switch. Then in 2019, researchers comparing the DNA of tailed monkeys and tailless apes found something unexpected sitting inside a gene called TBXT, a gene that controls tail development in almost every vertebrate animal on Earth. Inside this gene in every ape, including humans, there was a tiny extra piece of genetic material that did not exist in tailed monkeys. A small fragment of DNA that had inserted itself into the gene at some point in ape evolutionary history. This type of fragment is sometimes called a jumping gene. These are small pieces of DNA that can copy themselves and land in new locations throughout the genome. The human genome is full of them, over 1 million copies sitting quietly in our DNA doing almost nothing at all. Almost nothing. This one landed in exactly the wrong spot, or depending on how you look at it, exactly the right spot. That insertion changed how the TBXT gene was read by the cell. Instead of producing the normal protein that builds a tail during development, the altered gene started producing a shortened version that disrupted tail formation entirely. To prove this was actually the cause, researchers took this specific genetic change and engineered it directly into mice. And the mice grew little to no tails. A single tiny piece of DNA landing in one specific location inside one specific gene was enough to remove the tail from an entire lineage of primates. Every ape alive today, every human who has ever lived, carries that same ancient genetic accident inside every single cell of their body. Here is where the story takes a turn that most people never hear about. When researchers created mice with this engineered genetic change, the mice did not just lose their tails cleanly. Some of them developed problems with their spinal development during the early stages of growth, specifically defects in the neural tube, the structure that eventually becomes the brain and spinal cord. This means the mutation that removed the tail in ancient apes may not have come alone. It may have come with an increased risk of a serious developmental problem. And here is the part that should genuinely stop you for a moment. Neural tube defects are still a real concern in human pregnancies today. They affect a meaningful number of births every single year worldwide. It is exactly why doctors tell pregnant women to take folate supplements, to reduce that specific risk. Scientists believe the folate connection and the ancient tail mutation may be linked. The same genetic change that removed the tail from your ancestors millions of years ago may have quietly left a vulnerability in human development that doctors are still managing today. Ancient apes carried this genetic change forward through millions of generations anyway, which means whatever advantage came with losing the tail was significant enough to outweigh that increased risk every single generation for 25 million years. That is how valuable the tailless body plan turned out to be. The tail did not completely disappear. It just became something else. Right now at the base of your spine, you have a small cluster of fused bones called the coccyx. Most people only notice it when they fall hard on a hard surface, and it hurts for weeks. But that bone is not random leftover anatomy. It is what remains of the tail your ancestors carried for hundreds of millions of years before the genetic accident that switched it off. And here is something even stranger. Every human embryo still grows a tail during early development. Around 4 to 5 weeks after conception, a human embryo develops a genuine tail structure with real vertebrae. For a brief period, a human embryo looks strikingly similar to the embryo of a mouse or a fish. Then the tail gets reabsorbed back into the body. The cells get repurposed, and by the time a baby is born, all that remains is the coccyx. The genetic instructions for building a tail are still in your DNA right now. They have never been deleted. They are just switched off before birth by the same mutation that switched them off in every ape ancestor going back 25 million years. Occasionally, very rarely, something goes wrong with that switch, and a baby is born with a small soft tissue growth at the base of the spine. Medical literature documents these cases. They are exceptionally uncommon, but they happen. A reminder that the ancient tail-building instructions are still sitting inside the human genome, silent and waiting. Here is the part of this story that connects everything, because losing the tail did not just change how ancient apes moved through trees. It quietly set off a chain of events that eventually led directly to everything that makes humans human. A body restructured around hanging and swinging below branches, rather than running along the top of them, developed very different shoulders. Broader, more flexible, capable of a much wider range of motion than the shoulders of four-legged animals. Those shoulders eventually allowed ancient humans to do something no other animal on Earth could do with the same precision and power. Throw hard, accurately, repeatedly. Researchers studying ancient human anatomy found that the shoulder structure that developed from millions of years of arms swinging through trees turned out to be perfectly designed for throwing projectiles at high speed. Spears, rocks, eventually arrows. The hunting advantage this gave ancient humans over every other predator on the savanna was enormous, and the upright posture that came with this restructured body eventually led to fully bipedal walking. 2 legs doing all the movement work meant 2 arms permanently free for everything else. Tools, fire, eventually building entire civilizations. All of it traces back to a single tiny piece of DNA landing in a single gene in a single ancient ape roughly 25 million years ago. No plan, no purpose, just a random genetic accident that happened to be useful enough to stick around forever. So here is the full picture. Ancient humans did not lose their tails because tails stopped working. Tails worked perfectly well for hundreds of millions of years and still do for every monkey alive today. Ancient humans lost their tails because one tiny jumping gene landed in exactly the wrong place, inside exactly the right gene, at exactly the right moment in evolutionary history. That accident changed how apes moved through trees. That movement change restructured the entire skeleton. That skeleton eventually stood upright, and those freed hands eventually built everything you can see around you right now. The next time you feel that small, awkward bone at the base of your spine after sitting too long on a hard chair, remember what you are actually touching. The last remaining piece of a tail your ancestors carried for hundreds of millions of years. Switched off by a genetic accident so small it fits inside a single sentence, but so significant that without it, none of what came after would have been possible. You lost a tail, and somehow that turned out to be one of the best things that ever happened to your species. If this makes you see your own body differently, subscribe. Every video on this channel does exactly that to something you never thought twice about.